let us see how density varies when temperature changes. So see here, we have studied change in volume number delta V is equals to V gamma delta T. This is what we have studied now. So change in volume of any liquid is equals to original volume multiplied by gamma multiplied by delta T, V gamma delta T. Now we know that density is equals to mass by volume, no? Clear number? Density is equals to mass by volume. So delta V can be written as V2 minus V1 also, no? Change in volume. This is equals to V1 gamma delta T. So therefore what is final volume? So V1 plus V1 gamma delta T. So V2 is equals to V1 if you take common 1 plus alpha gamma delta T. This already we have studied, no? V1 is initial volume, V2 is final volume. Okay? So density is equals to mass by volume. This is the initial density. So after changing temperature, okay, ma? So after changing temperature, what happens to volume? Volume changes, but mass remains constant, no? So density also will change. Okay? So if volume reduces, density increases. If volume increases, density reduces. This is what will happen. Understood, no? So definitely if volume changes, density also changes because mass is a constant. Okay? So after changing temperature, I will write a D dash. Final density is equals to mass remains same, and final volume I can write V dash. Clear, no? So if you divide both of them, what I will get? So this is first equation, this is second equation. Dividing both of them, I will write 2 divided by 1. Okay? So 2 by 1, I can write D dash divided by D is equals to M divided by V dash divided by M by V. Mass is same number, so mass get cancelled. So what I am left with, D dash is equals to D into V divided by V dash. This is what I can write. Okay? So D multiplied by V divided by, this is the final volume number. V2 is nothing but, V dash is nothing but final volume. So final volume, how I can write? I can write V multiplied by 1 plus gamma delta T. This is how I can write. So initial volume get cancelled. So D dash is equals to D into 1 plus gamma delta T power minus 1. This is how I can write. Okay. Now again I will expand this one according to binomial theorem. Binomial theorem means already we discussed, you know, this minus 1 becomes the coefficient of gamma delta T, and remaining terms we will neglect them. So therefore final density is how much? D multiplied by 1 minus gamma delta T. So this is the equation to calculate the final density when delta T is the change in temperature and D is the original density of that liquid. Understood, number? By this equation you can calculate final density. That's it. D dash is the final density, D is initial density, delta T is change in temperature. Okay, ma? And change in temperature, how you have to write? Always final temperature minus initial temperature. Okay? If final temperature is bigger, delta T will be positive. If delta T will be positive, D dash will reduce. That is, density reduces. Okay, ma? If T2 is lesser, then delta T will become negative. If delta T becomes negative, D dash value increases. Okay? So depending on that, I hope you can understand what will happen. Okay?